Hey, hello everyone, and welcome to the week 7 tutorial problems for the machine and mechanism A. So this week we're going to start to cover the topic that you already covered in the lecture, which is going to be the planar kinetics of the rigid body, the work and the energy. So we're going to solve some examples about the principles of the work and the energy, and we're going to start with the first one. So I think that you saw a similar example before about a road that's falling down, and we know we're going to have an omega, we're going to have an acceleration or whatever the thing is, we're going to have also work and energy. The work then going to make it fall, and the energy that's stored in this process. So here we have a 50 kilogram bar falls from rest. That's mean omega 1 is 0. So bear in mind the speed of its and b just before it's going to strike the ground. So we want to know what will be the velocity at the top point b just before it's going to be totally in the horizontal position. So we're going to have we know that the angle we're going to pass is going to be pi divided by 2. And we are going to calculate that accordingly. So we are going to start first by sketching the free body diagram you can see in front of you. We're going to have direction A, Y, and AX. And this position, which is going to be in the mid. The centroid will locate at the half of the bar. And then we're going to find the effects of the weight, which is 490.5 Newton, which is equal to 50 kilograms multiplied by the gravitational acceleration. So the solution has been provided to you. Say that the free body diagram is to be drawn first, then only the weight does work. And then we're again to use the equation that the T1 plus the sigma of the U from 1 to 2 is equal to T2. That's the work and the energy equation that we talked about. The omega is equal to 3.84 as the answer we need to find. Later, we're going to calculate the velocity at the point B is going to be found. By knowing what the omega is, we know what the R value is, and we can find it to be equal to 7.67 meter per second. So we are going to find that the bar undergoes a rotation about the fixed axis at A, and the diagram, as you can see here, just a bar with the centroid in the middle. That will be taken as a y-axis, this will be taken as an x-axis, and then I'm going to have the weight sitting in the middle, going downward, and we have, this will be the y-axis, and the theta is going to be the angle between the y-axis and the bar AB. At the point B, we're going to have the two reactions, AX and the AY. Now, let's look at the kinetic diagram. So in the kinetic diagram, we're going to have the centroid, we're going to have velocity at the point G. That will be affected by the falling of the bar by the velocity, angular velocity of the omega. So I can find the velocity here simply if I know what the omega is. I can to multiply the omega by the r ag, and I can find the vg. For the point B, it's going to be the same, but the length is going to be the whole length of the bar instead of half length of the bar. Now let's list the known value given to us. We know that the mass is 50 kilograms, the omega 1 is 0 when theta 1 is equal to 0, and then we know that the theta 2 is going to be when the bar is going to be at horizontal position, so it's going to be 90 degree. Unknown are going to be the omega 2 and then the VB2. The equation I'm going to use is the energy equation. So the T1 is equal to the sigma of the U1 minus U1 to 2, and this will be equal to T2. So we come to the solution. We know that the T is equal to the half of IA omega squared. The IA is the IG plus the mass multiplied by the RG slash A square. And then the RGA square is going to be equal to the length of the bar divided by 2 square. So this is the IA equation, and we can apply it to the value of the T. Now the T equation now is going to be equal to the half of the mass Vg square plus the half of the Ig omega square. That's the one we have here. Now the parameters, we know that the Vg is equal to the Rg slash A multiplied by the omega, as we mentioned earlier. and thus it's going to be the omega L divided by 2. The Ig is half 1 over 12 mass multiplied by the length square. So now we know all the parameters and we can start to apply the equations. You don't have to use both. You have to use one of them. That's for the A point, and that will be for the G point. So either of them can be used, and the easiest one to be used is going to be this one. Because I'm going to cancel that part here, because I don't know what the velocity G is. So now we're going to start to calculate the T1 and the T2. The T1, omega was 0. So I can say that the T1 is going to be equal to 0. And the T2 is going to be when the value of the omega is going to be equal to omega 2. That's something I don't know. Okay, so that will be the equation we're going to have. A T1 is going to be 0 because omega 1 is 0. T2 is 1 over 12 IA omega 2 square. And this will be equal to 1 over 2 multiplied by the Ig plus the IA. That's what we have here. So the Ig multiplied by the mass multiplied by the RGA square. Okay, so we're going to have the IA here is going to be applied here. Multiplied by the omega 2 square. By substitute what we have, we know the length, we know the mass, and we're going to get the value that the T2 is equal to 33.3 omega 2 square. Now here, in this equation at the top, T1 is 0, T2 is 33.3 omega 2 square. Now we're calculating for the U part. And for the U part, which is the energy, potential energy specifically, we're going to say that the only work is doing the energy. And the energy, as you know, is going to be equal to the force multiplied by the displacement. And that case is going to be equal to the weight multiplied by the change in the y value. Or is going to be the negative weight multiplied by the y2 minus the y1, or the height 1 minus the height 2. So we're going to apply all these parameters in, and we get the value to be equal to minus 50 multiplied by 9.81 minus 1. Now why minus 1? Because the y2 is 0. The y1 was 1 meter. So we're going to have this value. Now the negative with negative will make it positive. The 50 times 9.81, which is the acceleration multiplied by the mass, to give me the weight, is going to be equal to 490.5. And thus I'm going to have that the energy is equal to 490.5. That's it. I just found everything in my equation. T1 is known, T2 is known, the delta, the sigma of the U1 to 2 is known. Then I can substitute everything in the equation, and I can find the value of the omega 2, which is going to be equal to 490.5 divided by 33.3 on the square root. And we will find that the omega is equal to 3.84 radian per second. Now, the last step, we just need to find the velocity at the length of 2 meters. So the velocity is going to be equal to the omega 2 multiplied by the distance from the A to B, which is 2 meters, and this will give me 7.68 meter per second as an answer.